Hey everybody, BTO Pro here. This is a talk that I originally gave at Drupal Camp PA in 2017. It's a lightning talk, so that's why I'm going to be talking fast. So my talk today is snaking HTTP calls in ELMS Learning Network. We got a bunch of snake emojis, so already immediately like, why is there snake emojis here? Well, for another useless example, we've got HTTP snakes on our network. What are we going to do with these? Well, first we got to figure out what they are. So I am calling a snake call, a call in which one HTTP thread goes out the door, goes to a server, the server is working on something, and it's about to run out of memory, so instead of canceling, it actually fires the same call back to itself, thus closing the original thread and recycling and starting anew. So you have much longer calls that go on, and this is just a screenshot of this comment to suggest why I'm doing this talk, because I knew at some point I would rant about how awesome this is. So why did we need to make this? Well, we work on a platform called ELMS Learning Network. ELMS Learning Network is a special type of system. It's called an NGDLE, or Next Generation Digital Learning Environment, which basically is a lot of systems acting as one. So you got to pass data around to all the right places. So really quickly, you might be here, and then you might go here, and then you might go here, and we have a consistent user experience. But one of those wicked problems in all this Iron Man crazy stuff that we have to get to has to do with user syncing. Because how am I going to push a user's account across all these sources? That's a problem that happens because it's not a single point. So, for example, when you set up ELMS, we get 0 things called services and 7 Drupal sites, and 3 of those actually sync people's accounts, and in our initial registry, we've got 2 accounts. Yay, that was really easy to sync 2 accounts, right? But in a production instance that we have 98 sites, because part of the principle of ELMS Learning Network is that people can request their own sites, and it kind of builds out this organic network. So we need to figure out the topology of the network, and then we need to send the accounts to the right places. Not every site's can have all the same accounts. However, now our people registry has 11,000 accounts. And most courses have 1,000 to 2,000 accounts, and the sections, the thing at which we sync up against, is about 50 to 180 users in our use case. That all sounds like a lot. However, the other day, going through and different vendors' solution, it was Buttercups, is a training company that uses our software, and they've actually got 100 Drupal sites using this, and they've got 57,000 accounts. And they were having sections come across with 6,000 users. And what that leads to is epic fail, because 6,000 users is not what it's meant to do. And so what are we going to do? Well, we recently rewrote this code. They helped sponsor some code to be built, and we recently got it in, and it's using the queue API. Now, the queue API is available in 7 and 8, and it basically, if you know what a queue is, it's just kind of an array, and you push the values in, and it helps manage getting values in and out of the array. A very simple principle. Effectively, you create the queue, you add items to it, and then you're off and running. So will it blend? We put 10,000 items in this case, because this was our test bed, into a queue, and we fire it. But that's still going to fail because we're still processing 10,000 items. So the queue part didn't actually matter in this example. We only got to about 3,000 users before we time out. So what we do is we batch things, and so the queue will only process up to a limit. In our case, it's 1,000. And then when it's done processing, it stuffs the queue back where it was, and then fires off this HTTP snake to do it again. So will it blend? We got 10 times into this thing, split that by 1,000 users, and it does sort of. So in this case, we had to use cron actually, not the snaking approach we're going to mention in a second. And so cron would run 10 times and it would work, but I want it to happen immediately. I don't want it to happen eventually. And so that's where snake comes in. So the snake stack is actually visualized like this. When it's about to escape, it goes, hey, I've got 1,000 users, and then it goes, okay, well, now fire that call off. It didn't finish. And the queue picks up, and it gets the next 1,000, it processes them, and it goes, oh, I didn't finish. And it calls itself, and it just keeps calling itself over and over again. So will it blend, where we have these people going across? Yes, but we don't actually just have one site. So what we have to do is we have to go into the course and we have to say, hey, roster source, you're actually going to have to sprinkle yourself across this other system. And so our first system goes, hey, I didn't finish. And then it adds itself to the end of the snake stack. And it says, well, who am I calling? Well, it's the second system. The second system says, hey, I didn't finish. So it adds itself to the end. And the second system doesn't finish. So it sends to the third. And the third says, hey, I didn't finish. And it sends to the fourth. And the fourth goes, hey, I didn't finish. I'll add to the end. Oh, what's the next thing? It's actually the first one that I have to do. So it actually iterates over these, but it's only generating one HTTP thread the entire time. So while this might take 6-7 minutes to accomplish in this little scenario here, it's not going to die. That's the important thing. The server's never going to get overloaded, and it's not going to use a ton of RAM to do it. But we don't just have one course. We have hundreds of courses in the scenario. So what you end up getting is effectively this, where it goes out, the initial queue goes out the door, and it goes to 1, and A to B, and B to C, and D back to A, and then it does it for the next course, and the next course, and the next course, and the next course. We just keep going and going and going because it's effectively a form of infinite scale, the way at which this is going to happen, right? It might take 20, 30, 40, 50 minutes to sync all of these people, but the point is it's not going to time out, and it actually can sync all these people. So even if we send, 100,000 users at this, we're fine. And so then we hook that part up nightly to trigger that thing, and we've got all kind of HTTP snakes all over our network, and we've got all kind of users all up in our user tables. If you want to learn more about ELMS, you can go to elmsln.org.